It's looking a lot more like AI is capable of reading our thoughts. However, this discovery goes even deeper, all the way down to the tissue of our brains, where researchers employed AI to convert brain scans into text. As advances in artificial intelligence continue to unlock the mysteries of the brain, scientists have figured out how small creatures such as fruit flies perceive their surroundings. This achievement, which was obtained by training an AI model on the visual system of a fruit fly, is more than just the fly's perspective. It opens the door to a better comprehension of human vision, as well as the development of artificial vision technologies. Welcome back to AI Mastery Collective, the place we dive into the deep world of technology. There is a reminder, if you have not yet subscribed to my channel, make sure you subscribe and ring the notification bell so that you don't miss out on any newly uploaded videos. Now let's dive in. Fruit fly vision. It has long been said that a person's eyes are a window into their soul. This implies that our eyes serve as windows to the outside world. What we see and how we perceive it helps us understand our environment and make decisions about how to act. This encompasses our social interactions as well. Now, a researcher at Cold Spring Harbor Laboratory and his group have discovered a crucial piece of information regarding the operation of this process. They did this by developing a unique artificial intelligence model of the brain of a typical fruit fly. Possibly the most significant organ in our body is the brain. Everything we do is controlled by it, including basic functions like breathing and more complicated ones like watching videos or reading books. It's fascinating that the structure of a fruit fly's brain is nearly identical to the neural network used in modern artificial intelligence. Neural artificial intelligence networks are AI systems that have been created to imitate the structure and function of the brain, allowing them to operate similarly to real brains. Throughout their lives, fruit flies are able to recognize, learn about, and make decisions about every person and thing they come into contact with. This indicates that fruit flies, despite their small size, have highly developed brains that aid in their ability to navigate and react to their surroundings. The goal of the scientist AL model is to simulate how the fruit fly's brain absorbs visual data. The researchers can learn further about how vision affects behavior by examining this model. The fruit fly is a perfect model for this type of study because, despite being far simpler than the human brain, it functions according to similar fundamental principles. This AI model of the fruit fly brain enables researchers to investigate the processing and decision-making processes of visual inputs. How does a fruit fly, for instance, identify an object and choose whether to approach it or avoid it? How does it communicate with other flies using visual signals? Understanding these processes in fruit flies can help scientists understand more about the fundamental principles of vision and behavior that are used by many species, including humans. This research could potentially lead to advancements in our knowledge of human vision and social behaviors, as well as how our brains process visual information to direct our actions. Additionally, by closely examining the fly brain, researchers can comprehend how flies see objects, pick up new information, and make judgments. Then, this data can be utilized to comprehend the functioning of the human brain and other animals. However, the goal is to apply these findings to develop AI systems that can think and learn more like biological brains. How they did it. Benjamin Cowley, an assistant professor, and his team used a technique they developed called knockout training to improve their AI model. This is how it operates. At first, they observed and documented the actions of a male fruit fly attempting to win over a female fly. They saw that as part of the process, the male fly would follow the female and sing to her. Afterward, they silenced or turned off particular types of visual neurons in the brain of the male fly using advanced technology. These visual neurons are the ones responsible for processing what the fly sees. After these visual neurons were turned off, they trained their AI model to recognize any behavioral changes in the male fly. They repeatedly carried out this procedure, constantly turning off a distinct kind of visual neuron in the male fly's brain and training the AI to predict the reaction of the fly upon spotting the female fly. They were able to train the AI to precisely predict the behavior of the real fruit fly in response to diverse visual stimuli by doing this with several kinds of visual neurons. With this, they were able to think about how certain neurons contribute to behavior and use computers to predict brain activity. Previously, Researchers believed that a single kind of neuron linked every visual aspect to a particular action, but Cowley's group demonstrated that there is more complexity there. Multiple neurons interact in various ways to determine the fly's response to what it sees. The future. This development raises the possibility that artificial intelligence may one day forecast human behavior, despite the fact that human and fruit fly brains differ greatly. For instance, the human brain has approximately 100 billion neurons, whereas the brains of fruit flies have only 100,000. The huge difference in complexity makes it far more difficult for AI to predict human behavior. But Cowley believes that one day his AI model will assist us in understanding the algorithms that underlie the human visual system. Finally, scientists hope to eventually expand their expertise and create AI models capable of handling more complicated brains by first studying simpler systems, such as the brain of a fruit fly. Although it is significantly more difficult to predict human behavior, Cowley and his team's discovery represents a significant advancement in that approach. It lays the foundation for future advances in our knowledge of how our brains respond and react to what we see. We are headed to the end of this video. Thank you for hanging on till the end. Don't forget to write your thoughts in the comments section and share this video with your friends. Hang on with us to watch the next video as soon as we upload it.